everyone, I'm Tatiana, a Docker captain, DevOps consultant, and someone who helps AI not just chat smartly, but actually do useful things. So, today I want to tell you how models like GPT and Claude went from just talking to actually acting. You can think of it as them getting hands. And by hands, I mean agents, helper programs that let the model trigger real-world tools. For example, send a message in Slack, check a payment in Stripe, or open a pull request on GitHub. No magic needed, just MCP, an open standard called the Model Context Protocol. It gives language models a consistent, secure way to interact with external tools, from APIs to databases to cloud services. But getting to this point wasn't easy. So, let's talk about what made this hard in the first place, how it works today, and how Docker helps keep the whole setup clean, isolated, and easy to deploy. Let's start with where the pain used to be. You see, AI has always been a great advisor. It can write code, help find bugs, or even craft a poem if you are feeling down. But the moment you asked it something simple like, "Hey, can you post in Slack that the task is done?" it would just look at you and say, I'd love to, but I am just a language model. I can talk, but I can't do. And yeah, it makes sense. It's smart. It just couldn't act on its own. The brain was there, logic, knowledge, and clear reasoning, but actually taking action, that wasn't part of the job description. To close that gap, developers started giving models a way to act by connecting them to small helper services called agents. In the world of MCP, these are known as MCP servers. And the app that connects the model to those servers, that's called the host. Here is how it works, step by step. The model says what it wants to do, like send this message to Slack. The host takes that request and passes it to the right MCP server. The MCP server performs the action, sends the message, makes the API call, whatever. The host takes the result and gives it back to the model, so it can finish its reply. Simple. The brain thinks, the hands act, and MCP is a cable that connects them. But here is the catch. For a long time, setting this up was painful. I mean, it sounded great on paper, but in real life, total hacker quest. You had to spin up MCP servers manually. Each agent had its own messy stack: Python, Node, Chromium, conflict city, API keys, sitting in raw JSON. Easy to use, terrifying to manage. And if you wanted 2 or 3 agents, brace yourself. You just wanted to check a Stripe payment and suddenly you are deep in DIY DevOps. And that's where Docker comes in. It made launching MCP agents simple, consistent, and reliable. So imagine this, your AI finally gets hands, but you don't want those hands poking around your system. It's like Docker gives those hands gloves, clean, contained, and safe. The model gets the freedom to act, but the boundaries stay in place. Each agent runs in its own container. It only sees what you allow. No mess in your system, no library conflicts, and no, oops, I just deleted my desktop. So, what is changed? Now, Docker comes with the MCP Toolkit, and with it, an official catalog of over 100 ready-to-go agents. You open Docker Desktop, go to the MCP Toolkit tab, and they are right there, ready for action. So what actually happens when you use an agent? You pick an agent image, let's say GitHub. Docker spins up a container, the agent starts listening for commands from the model. That's it. No console gymnastics required. Now, let's talk about another problem: duplicated agents. Back in the day, if you ran multiple apps like Claude, VS Code, whatever, none of them knew the agent was already running, so each one spun up its own copy. That meant things got messy. Two containers doing the same job, two access tokens, two network connections, and a whole bunch of wasted resources. It was clunky, risky, and just unnecessary. Now, one agent, one container, multiple clients can connect to it. No duplication, no conflicts, no extra overhead. But is it safe? Yes, and here is why. Agents run inside isolated Docker containers. Each container gives you a clean, controlled environment. The agent only sees what you explicitly share: folders, environment variables, network access. Docker handles the isolation by default. It puts a strong boundary around your agent, keeping your system safe from mistakes, bugs, or even compromised tools. Still, as with any software, it's smart to check what it's doing under the hood. Stick to well-maintained agents, follow best practices, and you are in good shape. And sure, like with any powerful tool, you can override that. If you add -- privileged or mount the Docker socket, you are disabling that boundary. But stick with the defaults and Docker takes care of the hard parts for you. So, who is this actually for? If you are already using GPT, Claude, or Copilot and want them to actually do stuff, not just write about it. If you are in DevOps and tired of scripting the same tools over and over, or maybe if you are a product person and want AI wired into Jira, GitHub, Stripe, or whatever in 10 minutes flat. Then here is what you actually get out of it: an agent up and running in just a couple of minutes, built-in isolation and safety. And if you want to scale up, just add more agents. It's that simple. That's it for today. If you found this helpful, leave a like. It would honestly make me happy. Subscribe if you want more DevOps, cloud, and automation. Join our Discord community, links in the description. And tell me in the comments, what would you let AI handle for you, and which agent do you want to try first? Thanks for watching, and I'll see you soon!